gate is logical gate are like logical doors, mean when you are interested that current pass through this gate will be allowed to current pass, and when you are interested that gate must be closed and current must not pass through the circuit, then it stop the current. So, logic gates mean the circuit which work as which allow the current and stop the current when we are interested to allow them and to stop. There are different type of the gates. Okay, we will study that will be OR, like AND, okay, NOT. Furtherly, these gate will be divided into the NOR, NAND gate, NOT AND gate, okay, exclusive OR and exclusive NOT gate. Today we will study, we will discuss about the OR gate, firstly OR gate and AND gate. Let us start from the OR gate. What is the OR gate? Okay. OR gate is the symbol for representing the OR gate like this, and they may have may have 2 input or 3 more than 2 input. They may have 3 input or more than 3 input. They may have 2 input, 3, 4, 5 and any finite number of inputs, but equal or more than the 2 input, not 1 input, okay, for OR gate or AND gate. Okay. Or you may say that this C will be actually the symbol to represent this, that will be A plus B plus C, and this will be output, not C, and this will be X will be output. Okay. And this may be as I have already told that may be have n number of input, they may have any number of the finite number of input, may you say that is 1, 2, 3 up till n, and X that will be 1 plus 2 plus 3 plus logically represent the summation, and that may be a 1 plus 2 plus 3 plus up till n. That depend upon the number of input. If there are n input, then that will be n. What is the meaning of this logic gate? This logic gate meaning that if any input is high, okay. So OR gate mean if anyone is high, any voltage is high, then input then output will be high. What is meaning? For OR gate, if any input is high, then output will be high. In other sense, you may say that if all input is low, if anyone is high, then output will be high. If all input is low, mean no one input is, then output will be all low. This is a logical diagram. This is the diagram. This is about the logical gate. Okay. What type of the circuit? We draw the circuit. For example, if there are 3 input, that is a 3 forward bias diode. Okay. Okay. If there are 2 lines, this is 5 volt and this is a 0 volt. Okay. If anyone is connected, let us suppose if anyone is connected with the positive 5 volt, the diode, for example, if anyone is connected and remaining all are even remaining all one, all diode are 0. If the any diode is belong to the 0, that will be diode will be if these are the input, let us suppose this is a input are A, B and C, if these are the 3 inputs. Okay. So, if anyone is connected with the plus 5, then P will become a more, this is as we know that these are the P and these are N. If any is connected, if P is connected with the positive volt and N is connected the negative volt, then it will, if P is connected with positive, then N will be at lower volt, okay, because output will be connected the ground. Okay. So, as we know that the output will be connected with the ground. Okay. So, if anything will be any diode is connected with the positive volt, then the current will be this diode will become forward bias and the current will pass through this this diode and the at output will be 1. Okay. This is circuit, and what is the okay, firstly I explain it, then I will draw the truth table. If any diode input, if any input is low, then diode will be, if that is connected mean P, then diode then the P of diode will be low, okay, and reverse bias, open circuit. No current will flow from this diode. Okay. Then P of this diode, so only for about this, that diode. Okay. So the P will be then P of this diode will be low, mean if any is connected, for example, if C is connected, then this this diode will be treated open and this will be a close. Hello. Okay. So, if any input is high, then that diode will be forward bias and circuit will be and behave like short circuit. So, current will pass through it and output will be high. For example, if B is high, then the current will be passed through this, okay, this, and this will be treated as open. No current will be passed through, but the current will pass through this. If anything is high, then output will be high. Okay. So, it means if we combine these both, it implies that by combining both these, this implies that both will be implies that if any input is high, then output will be high. So, this is the about the circuit diagram. This is about the explanation of our you may say that the equivalent circuit of this is like current will be passed through. So, output will be high like this. Okay, this circuit. So, output will be high. If we draw a truth table for that, A, B and C. Zero, 1, 2, 3, 4, 5, 6, 7. Okay. Then output will be our output will be 0 for everything that will be 1. Okay. When any input is high, then output will be high, as I explained in the case of. So, this is all about the OR gate, but if for example, if there is exercise like that, there are 3 inputs let us suppose A, B, C. So, what will be the output? Let us suppose this is okay. For output, what will be the value of output? If any data is if any input is high, this A, B, C, these are the 3 inputs for, let us suppose this is A, B and C, these are 3, and this is X, that is A plus B plus C. If an input is high, then output will be high. So, if I draw the perpendicular layer where the changes occurred like this. Okay. If any input is high, then output will be high. Okay. So, what will the result if I represent the output with the blue? For instance, for this time all is 0, so that is 0, but B is 1 for this time B is starting, and maybe other are and B will be end on this, and this point this red line every will become a 0 again, and For this time it every number every input is 0, but for this a input is 1, that is why this will become a 1. For this only for at this red line there is glitch, mean that is not data, this is like a glitch. Okay. If this glitch is on, so that is why that will be on, but from this at this time for this red line a become positive and then it become a 0, but b start to positive. So, that will remain the positive even if for this input a is 0, but b will remain the 0. So, output will remain the, because b is positive. So, that will remain the positive, and at this point this become a 0. Okay, this become a 0, but a is still positive. So, that means that will remain the positive, and this will be this, and this so this will be the output, and remaining for our time, that is 0. So, this will be output. Okay. Why it become a it is become a 0, it's but this start to positive. So, that's become a this is a 1. So, that is why that is 1. At this point this was 1 and this one was this 0, but that will be, because any one is 1, that will, this will be for out OR gate. Okay. So, this is for all about the OR gate. Okay. But what is the input, what is the diagram for the, if this is about the OR gate. Okay. OR gate. Okay. Now, about the AND gate. Okay. So, what about the AND gate? This is all about the OR gate. Now, about AND gate. AND mean if all are high. Okay, this is our if any one is high, if any input is high, then output will be high. But in opposite to OR gate, if any input is low, all will be a low, and that is opposite to the OR gate. OR gate is representing by, it is denoted by this shape. Okay. And they may have the 3 input or n input, and x in output is representing by a dot b dot c. It may also have a more than it may also have a 1, 2, 3, and x will be 1 multiple of n numbers. Okay. So, it is representing the output. So, in this way here is the summation, but there is will be a multiplication. Mean, as we know that in multiplication, when we multiply 0 any number, then the answer will be 0. Mean, if any input is low, then output will be if any input is low, then output will be a low. Okay. So, why that is AND gate, that is the main reason, and why that is representing by the multiplication, that is the main reason. For AND gate, any input is low, then output will be low. Or you may say that as we have discussed in the case of OR gate, if all input is high, opposite to this, okay. There was, if all input is low, then low, but in this case, if all input is high, then output will be high. If any input is low, if in the OR gate, if any input is high, then output will be high. But in the case of AND gate, if any input, no sorry, if all input is high, if all input is high, then output will be high. So, this is the for the case. What type of the truth table of OR gate, AND gate? If I draw the truth table of AND gate, like to compare, I will draw it here because I am just to compare this OR gate. The same truth table as input, you have whose the these are, okay, this is A, this is B, and this is C. This is output, and this will be what will be the output. If any input is low, then output will be a low. That mean that will be a 0 if any input is low, and output will be a low. But it will be high for only when all input is 1, as I have already explained. If all input is high, then output will be high. Okay. If any input is low, then output will be a low. So, that is the what type of so this will be a truth table for this for that was OR gate, and that is for AND gate. So, according to diagram, what will be output for this x equal to A dot B dot C. If all input is high, here for this time this is 0, this 0 at this time. If we see that at this time every all input is high, and here is this 0, and at this point all input is high, and this point and this point, and remaining for remaining that mean here from up till here C is low. So, यहाँ तक C is low, but C is high, but now A and B is low. Up till this C is low, so the output will be low. But here again C is low. C is here C is high, but A and B is low, so output will be low. Here C is high, A is high, B is high, so input will be high, but for C is high for this time only. Here C is high for this interval, but A is low, so no. Okay. B is A is high here, but B is low. Okay, so that mean no. So that will be the output, because here only this time this is only for only this glitch. C is for only this glitch, everything is high. Remaining here, if C is going to high, then all other are low. Here C is going to high, but A, B is high, so that's why this high. But else this C is 0 low, so that mean output will be low. Here output again here C is high and A is high, but B is low, so that mean no output. So that this will be only the this glitch. Oh, sorry, this glitch will be only output will be this glitch. Okay, the remaining all the time this will be a 0. So only this will be the output. So this will be the output of the output wave for the OR gate, and this will be output gate for the for AND gate. What will be the circuit diagram? Opposite to OR gate, in OR gate we have used the forward wise diode, but in this we will use the reverse wise, like it depend on the number of diode will be depend upon the number of input. If there are 3 input, then there will be a 3 diode. If more than 3, then the then depend upon your circuit. Okay. This is a 5 volt. Okay, this is a plus 5 volt. This is a 0 volt. Okay, this will be our result. Okay, this will be circuit. Okay, according to this circuit, if any if any input is low, okay, for example, this is low and this is high and this is high, then what will be happen? If in this case, as I have explained in, if any input is low, if any input is ground or low, okay, like if C is, then current this will become a forward bias, current will be passed through this. I mean, this circuit is equivalent to, I may say that I made let me draw it. These are the open, okay. So, all current will be passed through current will pass through, because this diode will be forward bias and that will be treated as short circuit, and no current will be passed through this X 0, no current will be passed through output. Okay. If because all current will be passed through, if any one is low, if any input is ground or low, then diode for this input will be forward bias and current and will be treated as short circuit. So, that will be treated as a short circuit, okay, and that will be okay. So, that is why the current will pass through, and output will be and output and output will 0. Okay. For this case, output will be a 0. Okay. But for high but for high input, yes, for high input diode will be reverse bias and behave as open circuit. And current will not flow from that diode. But but if all input are high, then all diode will be reverse bias. Then if all input are high, then all diode will be a reverse bias, and acts like open. So, no current will pass through any diode, but only from output. So what will be happen? So, output will be high. So, output will be 1 or high. So, that's will be so all this is all about this. Okay. So, this will be output will be high. So, that is why that will be treated as and if all are high, then all circuit will become open. Now, all diode will become no current may pass through any diode. So, that will be then output will be then all current will be passed through the output, and that output will become 1. So, this is all about for OR gate and AND gate. Have you any question? Very simple. Next we will study the NOT and NOT gate, okay, and what will be the equivalent diagram. And in exam the different input diagram may become. So, please do practice for different inputs, okay. So, then the output will be a different. Thank you very much. Allah Hafiz.